In this video, we are going to tackle two complicated factoring problems. So I have an expression here that I want to factor, and we want to begin by finding the GCF, the greatest common factor between these two terms. But before I tackle this ugly factoring problem, let me take you back to a simpler, more basic factoring problem, because the process that we're going to use will be the same. So let's say I gave you 8x squared plus 16x cubed, and I asked you to factor this expression. It's important to remember that this expression has two terms, and we want to start by determining what the greatest common factor is between these two terms. So the 8 and the 16 are my leading coefficients, and the greatest common factor between 8 and 16 would be 8. And then we have the x squared and the x cubed, and we know that the greatest common factor between those two pieces would be the x squared. And maybe you had written it out when you first learned to factor, something like this, and then you perhaps circled, oh, this one has two x's, this one does as well, x times x is x squared, and that's why these both have in common an x squared. But once you got into the hang of factoring, you realize that these have the same base, they both have a base of x, and you factored out the smaller of the two exponents, the x squared, and that's how we determined what the greatest common factor was. And then once you know your greatest common factor, remember factoring means you're going to rewrite the problem as multiplication. So the 8x squared, which was our GCF, gets factored out, and what that means is we're really dividing both of these terms by the 8x squared, and that's going to help us figure out what remains here in my parenthesis. So we see that 8 divides into 8 once, x squared divides into x squared one time as well, so we're just left with a 1, plus 8 divides into 16 twice, x squared divides into x cubed, x to the first power, so that would be a 2x remaining. So it's this division here that helps us determine what's left in this quantity when we factor. So we're going to use this same idea to tackle this uglier factoring problem. So this expression also has two terms. So I'm underlining the two terms, and we need to begin by figuring out what our greatest common factor is. So between the 12 and the 16, the greatest common factor is a 4. Then we have the x squared and the x to the fourth. So our greatest common factor there is the x squared, the smaller of the two exponents. And then we take the same approach here with the x plus 3's. So because we have x plus 3 to the negative 2 power and x plus 3 to the negative 3 power, third power, the smaller of those two exponents is the negative 3. So we're going to factor out an x plus 3 raised to the negative third power because it's the smaller of the two exponents. So let me do a little erasing here. Here's our greatest common factor. So my answer down at the bottom is going to have a 4x squared times the quantity x plus 3 to the negative third power factored out in front, and now we are trying to figure out what the remaining piece is going to be here in these brackets. So we're essentially dividing both of these terms by this GCF of 4x squared times x plus 3 to the negative third power. And in the beginning, if it helps you to actually write down this division, there's no harm in doing that to make sure you really understand the process. So now, let's divide. 4 divides into 12 3 times. The x squared divides into the x squared once. And then we have this x plus 3. The top is raised to the negative 2 power, and the bottom is raised to the negative 3 power. And remember, when we're dividing in this way, we subtract our exponents. So it's the top exponent of negative 2 minus the bottom exponent of negative 3. In other words, we're going to end up with negative 2 plus 3, which will give us an exponent of a 1. So we end up with x plus 3 raised to the first power, but we know we typically don't write the exponent if it's a 1. So now moving on to the second term, we do the division. 4 divides into 16 4 times. Then we have x squared dividing into the x to the fourth. Again, look at the exponents. If you subtract your exponents, 4 minus 2 is going to be a 2. That's why we have an x squared. And then the x plus 3 to the negative third divides into x plus 3 to the negative third just one time. So we really just end up with a 4x squared. And this is going to be our factored form. And if you wanted to distribute in here, you certainly could. But you'll notice that if you did distribute, you wouldn't be able to simplify it any further. At this point, I can change my brackets to parentheses, but I'd end up with 3x plus 9 plus 4x squared, and I don't have any terms here that are like terms. So I really can't go any further with this. This would be my factored form. Here's our second complicated factoring problem. Again, this is an expression that has two separate terms. Those terms are separated by that addition, and we need to start by determining our greatest common factor. So we have 25 and 10. The GCF between 25 and 10 is 5. Then notice here we have x to the 1/3, and this is x. Let me write this down below. X to the 1/3, and this is really x to the first. So they have the same base of x, so we're looking at the exponents, and we're going to choose the one that is smaller, which means x to the 1/3 will be the GCF between those two. And then the same thing goes for the x plus 4 to the second, and here x plus 4 to the first. So once again, looking at the smaller exponent, if we have x plus 4 to the second and x plus 4 to the first power, then we're going to be choosing x plus 4 to the first because the exponent is smaller. So the base is x plus 4, and it'll just be to the first power. So there's our GCF. This is what we're going to factor out. So in our final answer at the bottom, we will have a 5x to the 1/3 power times an x plus 4. That'll be factored out in front, and then we're going to try to figure out what remains here. Remember, to factor is to rewrite as multiplication. So, once again, if it helps you to go ahead and write down the division that you're going to be doing here to factor, you're going to divide each of these terms by the GCF. So I'm writing down my division here, and now we will divide. 5 divides into 25, 5 times. The x to the 1/3 divides into x to the 1/3 once. And then here we have x plus 4 to the second divided by x plus 4 to the first. So those will divide in, and we'll be left with an x plus 4 on top to the first power. So we have 5 times x plus 4 plus the second term. 5 divides into 10 twice, so we'll have a 2. Then here we have x to the first over x to the 1/3. Let me write that mini problem down below so you can see this piece. So we have to subtract our exponents. 1 minus 1/3 leaves us with an exponent of 2/3. So that's x to the 2/3 power. And then x plus 4 divides into the x plus 4 one time. That divides out. So we're left with a final answer here of 5x to the 1/3 times x plus 4 times the quantity 5 times x plus 4 plus 2x to the 2/3. And once again, if you wanted to distribute here, you certainly could, but you wouldn't be able to combine any like terms inside of this big bracket. So this would work for your factored form.